Hi there, my name is Chris Reed, and in this presentation I'm going to talk about my final database project that I did for my Principles of Database Systems class. Here's an agenda for the presentation. I'm going to start off by talking about the project description and the motivation for choosing this project. Then we'll talk about the scope of the project and the tools that were used to design and implement the project. Then we'll move on to looking at the conceptual database design by inspecting the entity relationship diagram. Then we'll move on to the logical design by inspecting one table in detail. Then I'll show you some queries that two user groups might conduct. And I'll conclude the presentation by talking about some advanced features, future enhancements, and lessons learned from this project. For my database project, I chose to build a database that would help support a web-based test preparation application for students who are studying advanced placement calculus. The database consists of pre-built tests that have multiple choice and free response questions. The question style and format closely mimics the AP exam, which students would typically take at the conclusion of a year or two of high school calculus. The reason I chose this project is that I teach AP Calculus and I've been teaching it for the last 14 years. And every year I see the need for students to get more practice. So I thought that if I could create a database and in the future create a web application that could draw from the database, this would give students another opportunity to get some high quality practice. So a little bit about the scope of the project. In this project, I worked on the conceptual design, the logical design, and the implementation of the database. The web-based application hasn't been built yet and won't be covered here in this presentation. The tools that I used for the design and implementation were the following. So first, I used MySQL Workbench, which provided two pieces of functionality. One was it allowed me to model, to create the model for the conceptual design by building the entity relationship diagram, the ERD, and it also provided a database connection tool and a graphical user interface to help build the tables using SQL statements. I also used the command line interface, which is part of MySQL Workbench, to run SQL statements. To populate the database, I used three sources. I used a website called Fill Database, which provides dummy data for MySQL databases. I pulled the standards for AP Calculus AB and BC from the College Board's website. And I also hand-constructed several multiple choice problems that were placed inside the database. So let's talk a little bit about the conceptual design. Here's an overview of my ERD. There are 13 entities, 6 are strong, 7 are weak, and 17 relationships, 2 non-identifying and 15 identifying, which span from one-to-one, one-to-many, and many-to-many. Some of the constraints of the conceptual database design were many of the attributes were marked as not null, and each entity had a primary key, and some of those primary keys migrated to become foreign keys of other tables. And in doing so, this helps enforce the entity integrity and referential integrity constraints. I also included several triggers which were used to monitor and force particular database updates. Let's go ahead and take a look at the ERD from MySQL Workbench. Here's the ERD from MySQL Workbench. The blocks in this diagram represent entities, and the ones that have sharp corners are strong entities, whereas the ones that have rounded corners are weak entities. Identifying relationships are marked with solid lines, and non-identifying relationships are marked with dashed lines. Let's go ahead and zoom in at one of the entities so we can look at it in detail. We're going to look at the test entity. we can see that the test entity has 7 attributes, one of which is a primary key, test underscore ID. We can also see that there is a foreign key here, course ID, which has been migrated from the course entity. And notice its position in the diagram. It is not part of the primary key because this is a non-identifying relationship. If it was an identifying relationship like we have here between test and test instance, then the key would take its place as part of the composite key. Let's move on to talking about the logical design by viewing a sample of my data dictionary. So if we think back to the ERD, each block in the ERD maps to a table that was created as part of the logical designs. So in the next floor slides, I show the create, insert statements, the resulting data dictionary, and the select statement for the test entity. Here's the create statement for test entity. Notice that several of the attributes have been marked as not null, and here are their data types, which are shown in the middle. This table has a primary key of test underscore ID and a foreign key of course ID, which references course ID and course. One thing to note here is that this table had to be created after course was created because of the referential integrity constraint. It would not work if I tried to create this table test without course table existing first. Here's the insert statement for the test entity. This is where I populated the table with 2 rows of data for test AB1 and test AB2. And here's the resulting data dictionary for test entity. This can be shown for any table in the database by using the SQL statement describe and then the name of the table. Here's a select statement showing the data that's currently in the test table. Notice here we have 2 tests, test AB1, test AB2. Here's the test topic, which was of data type text, which allows for a long string. So here what I had to do is limit the display to 25 characters in order to get the table to fit on one screen. Here are the number of multiple choice questions, number of free response questions in each test, a difficulty gauge, course ID, and the total number of points, 11 for test AB1 and 21 for test AB2. Let's now take a look at an example query that one of the user groups might conduct. So one of the user groups is a student user group, and they would not be directly doing this query. This would be an indirect query by accessing the database through a web-based application. One related query would be for students would probably be to locate and return the solution of a particular problem. And maybe a student would want to do this after they have attempted a problem to see what the correct solution is or to see how the instructor solved it. So the access to the database from this user group would be, as mentioned before, indirect, and it would be implemented through using prepared statements to try to mitigate any accidental or malicious SQL injection. Here's an example of this underlying query. So we're going to select multiple choice solution text from solution MC where MC ID is equal to MC0001. Let's go ahead and take a look at this query in MySQL Workbench. Okay, here we are in MySQL Workbench, and right now we are looking at the table solution MC. Okay, so solution MC has an ID, multiple choice ID, and then in this column there are solutions to these problems in text format. Here it's not populated yet, but in the future we could put in solutions that include a diagram or solutions that include a video. And then here are the correct letter choices. So let's go ahead and run this query. Select MC solution text from solution MC where MC underscore ID is equal to MC001. If we go ahead and run this query, we get the MC solution text for multiple choice problem 1. And if we right click on the blob, binary large object, we can view the solution in the viewer. Okay. So here's the viewer that shows the solution in text format. Let's go ahead and take a look at some queries that would be conducted by the other user group. Now, the other user group for this database would probably be instructors, and they would be doing their query directly from accessing the database. So here's an example of one of the queries that an instructor might be interested in doing. Return a count of students who took a test on or after a certain date. So here we're selecting a count of student ID from the table test instance where the start time date is greater than October 24th. And what is returned is that 4 students have taken a test on or after that date. Here's another example query. Let's suppose that the instructor wanted to return a list of students' first names, last names, and email addresses for students who took test AB1 and scored less than 7 points. If you remember from earlier in the presentation, test AB1 had 11 points, so maybe if a student scored less than 7 points, that might be something that would concern the instructor and they want to get in touch with them. So here's the SQL statement to do that. We're going to select first name, last name, email address from student table joined with temp table, where the temp table is defined with this subquery. And then we're looking for where the student ID in the student table is equal to the student ID in the temp table. And this is the results of the query. So two rows were returned. Here's another example query for this user group. Suppose we want to return a list of multiple choice problems that have a difficulty ranking of 2 or greater. Well, to do that, we would select the multiple choice ID, which uniquely identifies each multiple choice problem, from the question MC table, where the difficulty gauge is greater than or equal to 2. One advanced feature that was implemented in the database was by adding triggers. So several triggers were implemented to help automatically update tables during inserts, updates, and deletes. And as an example, I'd like to show you one where if a student views a solution to a particular problem, then there's a global counter that's incremented through a trigger. So this might be beneficial for an instructor just to gather information about how many times people viewed a solution. That might be an indicator of where students are having difficulty with a problem, or perhaps where they're finding a description to the solution particularly helpful. So here are the 2 triggers that accomplish that functionality. I had to create 2 here, one for insert and one for update. And the reason that there's 2 of them is that a student may have never looked at this solution, and if they didn't, this will be their first time, so they'll be inserted into the table student accesses solution multiple choice. But perhaps they've already looked at this solution and they've come back to take another look, and if they've done that, then there's another trigger, which is an update after update. Let's go ahead and take a look at these in MySQL Workbench to see how they work. Okay, here we are again in MySQL Workbench, and right now we're looking at the table Solution MC Statistics. And we can see here that there's statistics on 3 multiple choice problems. Multiple choice problem 1 has been, the text solution has been viewed 12 times, problem 2 has been viewed 4 times, and problem 3 has been viewed 5 times. So now let's go to the table Student Accesses Solution MC. This is where my triggers exist. So here are the students that have looked at solutions, and right now I'm going to add another student who is part of the course, and their ID is 66 1247, and they're interested in looking at the solution for multiple choice problem 3. And they're going to view it one time right now. All right, so as a shortcut, we're just going to update the table here and press apply, which will automatically generate the SQL statements. Okay, so that was successful. And now we'll go ahead back and look at the solution MC statistics table. And we can see here that before, the number of times that problem number 3 solution was viewed was 5, and now it's been incremented to 6. Okay, so that illustrates the insert trigger. Let's look at the update trigger. If we go back to the student accesses solution MC, and let's say that student 656001 wants to take another look. They've already taken 5 looks at this solution, but let's say they want to take another look. So we'll increment this to 6. We'll click apply, and then we'll go back and we'll look at the solution MC statistics. And we can see that now problem number 3, the solution has been viewed 7 times. For future enhancements for the database, one thing I would like to do is populate the database with more test items, standards, and solution content. In particular, I'd like to add video content. Right now, the current state of the database includes solutions that are in text format, which is good, but I think it would be beneficial if we could get some videos in there as well. Something similar to what you might see on the Khan Academy. I would also need to, for a future enhancement, build and test a web-based client and server application. And then finally, once that's in place, to test the database performance and adjust accordingly. In terms of lessons I learned, this project provided a wonderful opportunity to learn by doing and help me develop a connection between theoretical database design and actual database design. It helped firm up my understanding of conceptual and the logical database designs, and it provided lots of practice in writing SQL statements. This was my first exposure to databases, and if I could go back in time to the beginning of the semester, I think the advice I might give myself is to perhaps pick a database project that was more generic and a little bit smaller in scope. Although I learned a great deal from this assignment, I think if I chose something that perhaps wasn't directly related to my professional duties, I might even be able to get more out of it than with the topic I chose. But I'm happy with what I did, but that would just be the advice I'd probably give myself if I could go back in time. Thank you for watching my database presentation. Here's a list of some of the references and resources that were used during the project.